Hi, I'm Rob Futrick. I'm the PM lead for Azure's HPC and AI software and services team. And I'm here today to give you an introduction to our platform. At Azure, we're a cloud built for HPC and AI. And I think this most clearly shows through the differentiated solution that we provide. It really gives our customers and our partners a leading HPC and AI cloud experience. And we build this because we are a genuine HPC and AI team. It's the platform we provide, it's the kind of benchmarks that we run, and really it's the people that we are. We are we are HPC and AI people that do cloud and not the other way around. And kind of a core part of our philosophy here is really to curate the technologies. This is a purpose-built platform. We have a deep understanding of our users' needs, the characteristics of their workloads, how they combine technologies to solve their problems, and the challenges that they face in doing so. And so we use that expertise to provide a very purpose-built solution that gives them leading performance, leading price performance, and overall an optimized and differentiated solution. And in doing that, we really provide leading kind of time to market for those technologies. We don't just provide everything. We use our kind of technical understanding, our business understanding, and kind of the economic understanding of the challenges our users face, and we use that to select the appropriate technologies to include in our platform. And this isn't a transactional relationship. We understand that this is a journey. Many of us have been doing HPC and AI for quite a long time, and we understand that this is an evolution of how our users and our partners do things, both with the new technologies we're bringing to market as well as the overall industry progress. And we're not here to just sell cloud. We're here to help people solve these problems over time. Now, across cloud and across other providers, everyone has kind of optimized technologies. They have compute optimized VMs. They offer low latency Ethernet and other kind of standard technologies. But Azure is unique. We offer InfiniBand connected HPC and AI clusters to really give you the best performance on real workloads. Again, that kind of shows up in the benchmarks that we run and kind of how we show our math for the platform we provide. And that's how we can achieve supercomputing scale and really meet the needs of the most demanding applications. And we're really the only one out there that provides this full range of HPC and AI capabilities. And some of our most recent accomplishments in June 2021, we had 4 supercomputers. Azure had 4 supercomputers in the top 30 of the top 500. These were not bespoke systems. These were just standard kind of supercomputers built out of Azure capabilities. And these are the first supercomputers to be listed by a cloud provider. And even kind of more importantly, this gives you a sense for what we are deploying as part of a global Azure presence. We followed that up in November of 2021 with an entry in the top 10 of the top 500. In this particular case, it was an AI supercomputer that was made primarily from NVIDIA A100 GPUs and AMD EPYC processors. Again, standard Microsoft technologies combined into what was a top 10 supercomputer. Now, kind of taking a longer view, this is kind of the history of our breakthroughs here, at least starting in 2019 when we ran a 20,000 core MPI job. We followed it up being the first cloud provider to provide AMD's EPYC Rome InfiniBand connected clusters. And those accomplishments continue across compute, networking, and storage. And really, this is giving us, or giving you, I should say, a sense for both the direction that we're headed, as well as kind of the seriousness with which we say we are a HPC and AI cloud company. As part of that, we have this purpose-built infrastructure I mentioned, and this is the full range of CPUs and GPUs that you'd expect. It's everything from dense compute optimized CPU offerings to memory bandwidth and memory latency optimized offerings. On the GPU side, it's everything from visualization, and then that could be partial GPUs for remote desktop, all the way through to high-end visualization offerings. It could be on the compute side, or even on kind of the mid-range inferencing, or even scale out training at kind of the high-end side, going back to that AI supercomputer built from NVIDIA A100 GPUs. Now, as I mentioned, we connect all of this with fast and secure networking. As I said, it's InfiniBand connected to give you that supercomputer scale and performance, but also we connect from edge to cloud. And so every part of your experience here, from getting to Azure to utilizing the technologies within Azure, is fast and secure connections. And then obviously we have to have that high performance storage, everything from disks to NFS filers and things like that, to blob storage, and even to parallel file systems, or even something like an HPE Cray cluster store. The full range of storage capabilities to support all of your workloads' I/O needs. Now, in some sense, this is a large collection of capabilities. These are different tools, different technologies. And where our platform really comes into play is on how you can combine those. And that's the workload orchestration side. We want to give you end-to-end agility, and we want to enable you to use known and familiar tools and processes, rather than force you to evolve or modernize or otherwise re-architect your solutions. We want to meet you where you are, and that's part of the goal of simplifying and enabling these cloud HPC and AI journeys. And that's more than just the specific solution or the specific technology. That's the end-to-end experience. We have a mission to provide world-class experience, everything from the moment you contact Azure through to defining and deploying these environments, to operating them over time, and then even in how you get your questions answered. When you run into a problem, when you'd like to incorporate a new technology, or even you'd like to try and optimize these systems, how do you get help? And our team focuses on that end-to-end agility and the end-to-end experience. So that kind of is captured by our mission. Our mission as the software and services platform team is to simplify cloud HPC and AI, and really HPC and AI in general. They're hard. HPC and AI are hard at scale. And it's by definition. If HPC and AI people and teams could be doing more already, they would be doing more already. So anytime we work with someone, they're almost always operating at the limits of their capabilities. It could be budget, it could be technology, it could be people, it could be some other dimension. But they're already operating at kind of a limit. And so, kind of like the Kernighan quote, if debugging is harder than coding, if you use all your cleverness when coding, then you can't debug. Well, if HPC and AI are hard and people are operating at the limits of their capabilities, then if we say come to cloud, but by the way, it's more difficult, that can be a similar non-starter. And so our whole mission is to enable our users to succeed, to unlock their agility, to unlock their innovation, and to really drive that transformation. And by removing any kind of cost or complexity, the cost of complexity in cloud along the way. So how do we fit into the Azure resource stack? Well, you have the compute, you have the networking, you have the storage options, and kind of like a box of Legos. You have all these pieces you can combine. And then we have the workload orchestration layer. And that's where Azure Batch and Azure Cycle Cloud and HPC Pack come in, the primary offerings from our platform. Today, we'll be focused primarily on Azure Batch and Azure Cycle Cloud. But note that we also kind of view ourselves as a bridge, or at least as a step along the way in accessing Azure's more transformative services as well. That could be Azure Machine Learning or something like Synapse or Quantum, something that more and more of our users are incorporating into their approaches as we move towards more an AI-enabled HPC and HPC and AI-enabled future. Now, our platform primary offerings, which we'll come into more detail in a second, also need to kind of, as I said, meet you where you are. And that could be primarily with standard tools and technologies. It's the job schedulers that you're already using or that you need, whether it's an open source tool like Slurm or PBS, or something like LSF on the commercial side, or even an in-house schedule that you've created yourself. It could be the workflow managers that you use, Airflow, Nextflow, Cromwell, etc. It could be in the support for both IaaS approaches and containerized workloads. If you'd like to containerize your HPC and AI workloads, or if you want to containerize your services and deploy them, we want to meet you there. And then, of course, the different toolkits and languages you need, whether it's something like PyTorch or TensorFlow, or specific language bindings, Python, Go, C#, you name it. And as part of that orchestration, we want to enable you to run those tools and technologies on the infrastructure of your choice. It could be our purpose-built technology, and that includes the various CPUs, GPUs, storage, and networking that our platform offers. But oftentimes, some of the most effective infrastructure that you want to use is the infrastructure you already have. So we understand that hybrid is kind of key to many of our users' current and future plans, and so that is another core part of our platform. And in this journey, and as part of simplifying the complexity and giving you the control you need, we want to offer you full clarity and control. That includes monitoring everything from telemetry and analytics on single VM performance or single container performance, all the way up through end-to-end traceability. And a very common concern is the risks of an unbound bill, or at least an unknown bill. And so rather than a fixed infrastructure investment, we want you to be able to dynamically take advantage of the infrastructure that you need for your business challenges. In order to give you the faith in that, we want to provide cost reporting and controls so that you can know who is running what, where, and at what cost. And then security is a must from the ground up. And so integrated governance and integrated security are clearly going to be factors. And that is all wrapped up in that end-to-end experience, everything from how you get your questions answered and how you get support for these critical workloads, all the way through into comprehensive training so you understand our platform and you can keep up with not only the offerings that we have, but how our partners and the open source community's offerings all kind of combine in these environments. And then we want to drive community engagement. We're not in this alone. We understand that everybody in HPC and AI and how those workloads and those technologies and those approaches affect all the different industries. Everyone wins when we all win, and so we win when everyone wins. And so we want to drive that community engagement. We want to drive that ecosystem development and kind of grow this for everyone. So back to our specific offerings, that kind of that's our philosophy. That's driving both our current offerings and really will help you understand where we are going in the future. But today we have two primary things. We have Azure Batch and Azure CycleCloud. Azure Batch is a cloud-native job scheduler. Azure CycleCloud is not a job scheduler. It is a way of Azure enabling or using industry standard job schedulers. So Azure Batch is HPC as a service, and today is purely Azure-based. CycleCloud is more of a traditional HPC scaling methodology using Azure, and it supports both hybrid and cloud native. So on the Azure Batch side, the first problem you have in the cloud is getting your infrastructure up and running. And so you have to define it and deploy it and auto scale it ideally. And so that is batch pools. That is the part of the batch service that is used for dynamic infrastructure. It's simple, it's extremely scalable, it's fully managed. You can run your infrastructure up and down as needed, which allows you to optimize your usage and obviously then your cost. Now, once you have your infrastructure deployed, you want to actually utilize it to run your work, to actually get stuff done. That's Azure Batch Scheduler, or ABS for short. It is extremely scalable, as with Azure batch pools. It's also full featured, and it's a cloud native job scheduler. What we mean by that is dynamic infrastructure, a global presence, 24/7 service availability, and kind of extreme burstiness and scalability and whatnot are first-class concepts for Azure Batch Scheduler. And so, it is a scheduler kind of born and grown in the cloud. And but like traditional schedulers, you can run any application. You can run containers, Windows, Linux, you name it. It is simple and powerful, and probably the easiest way to run batch workloads, especially at scale in Azure. And it'll do everything you expect. It will detect and retry failed tasks. It has simple workflow capabilities for dependencies, pre and post, you name it. As I mentioned, it's flexible, Windows and Linux. You can use almost every Azure kind of IS capability, whether it's on-demand VMs, Windows VMs, Spot VMs, Windows or Linux, etc. It is full-featured monitoring so that you can understand the execution of your workloads over time, and it does have built-in error handling and error reporting. And kind of critically, it's also a developer platform. It is aimed at people who want to SaaSify or kind of cloud enable their workflows. And so it supports all the common languages and runtimes that you'd expect. And as that developer platform, and also as kind of the native scheduling capabilities, it is the integration point for a lot of workflow managers. And so, using a workflow, you can maintain pipeline portability and kind of compatibility with your existing approaches if you're using one on premises. And run the workflow processes as batch tasks. And you can integrate things like blob storage as your storage locations. And that screenshot happens to be the first time that I saw Nextflow running on Azure a while back. And it supports Airflow, Nextflow, Cromwell, SnakeMake. You can see a lot of the integrations live on GitHub. So complementary to Azure Batch, you have Azure CycleCloud. As I mentioned, Batch is more of a developer-focused tool. CycleCloud is really aimed at kind of HPC administrators. This is your way of creating and deploying, operating, and optimizing HPC clusters and AI clusters in Azure. So if you would call up an infrastructure provider and order servers and file systems and networking gear and rack it, stack it, cable it, all that stuff, you can think of CycleCloud as your way of doing that in Azure, but in minutes instead of weeks or months. And like Batch, it's probably the fastest way to get started. It supports industry standard job schedulers, and conceptually, you can lift and shift your environments by deploying the same architecture that you use on premises, but in Azure. And it's not often the best way to run in Azure, but it's definitely one of the fastest and easiest ways, and provides a solid foundation for you to validate your solutions in the cloud, and then to optimize your execution moving forward. Like Batch, it has an orchestrator, so it does cluster auto-scaling. It's quite a full-featured and robust and scalable orchestrator. And the cluster definitions themselves are kind of captured as code, if you will, in a template format. And so as a result, you can do versioning and standardization and auditing of your deployments over time. And as an administration tool, it does have those cost reporting and control features that allow you to kind of link your usage to your spend and to manage and control your costs. And security, again, kind of a concern from ground up. And so it has integrations with Active Directory and Azure AD, full audit and event logging, and RBAC authorization control, et cetera. And whereas Azure Batch today is cloud Azure only, I should say, through the use of those third-party schedulers, CycleCloud allows you to use all your infrastructure. So many of our users deploy their HPC and AI environments in either a hybrid or cloud bursting model. Some also deploy fully cloud native. Now, in hybrid, it can be either directing some workloads to on-premises infrastructure and the rest to cloud. It can also be actually having workloads span on-prem and cloud. That's really going to be defined by the characteristics of your workload. I wouldn't recommend running a tightly coupled workload across both on-prem and cloud. But for throughput or kind of pleasantly or embarrassingly parallel workloads, that can be one of the easiest ways to achieve the scale in a cost-effective manner for yourselves. And I want to highlight the support for standard job schedulers. It's not just that we support Slurm and PBS and others. It's really that we want to provide a first-class experience for those. And this gets back to the mission to simplify HPC and AI by meeting you where you are. And so use the simple kind of expected interfaces. Use the existing configurations that you're running, whether it's complexes or queues or parallels, environments, whatever. And it is a traditional scaling methodology, so it's kind of familiar in that sense. And it does allow you to also Azure enable in-house schedulers as well. So quite a few of our users have written their own schedulers, their own systems over the years, and through some of the additional capabilities, something called ScaleLib, you can Azure enable them as well. It does enable multi-dimensional orchestration, which is a fancy way of saying that you want to scale beyond just cores. That might be memory. It might be data locality or data residency. It could be software licenses or even budget. And we also try to drive native integrations with our ISV partners. For example, IBM's Spectrum LSF actually ships with a Azure CycleCloud-based Azure connector as part of the official distribution. So here's some of our details of our Slurm integration. It is full support for the latest versions of Slurm, and that includes both throughput and MPI, or tightly coupled job topologies. We do work to do automatic configuration of things like GPUs, VMs with GPUs when we can, as well as to integrate with Slurm's job accounting capabilities. The link to the official project repositories there goes into more details about those integrations and how you can deploy Slurm environments, again, hybrid or natively in Azure. Similarly, we have some details here about our integration with PBS. A lot of kind of conceptually similar capabilities, but I do want to call out that CycleCloud supports both the Open PBS open source version, as well as the PBS Professional commercial version although you will have to work with our partner Altair for licenses there. And Azure Slurm, it supports both throughput and tightly coupled job topologies. And one additional capability PBS has is you can actually get some flexibility and some insight into the auto-scaling decisions and the orchestration decisions through the AZ PBS CLI. So we spoke last year at SUSECON. I wanted to give you a sense of what has kind of progressed in our platform since then. At the service level, there's been a big focus on simplifying the service and improving stability and scalability and security. And so we have simplified the compute node communication model. Simply put, this means that essentially the nodes, the VMs now phone home to the service. That actually improves the overall security, and it simplifies the configuration and deployment of batch pools and batch deployments. For batch pools in particular, we've added support for spot VMs. We've done a ton of work to make the service kind of more automatically detect and recover from any kind of issues, both on the server side and on the user side, and a lot of kind of Azure platform keep up. So I won't go through the full list, but things like virtual machine extensions, user-assigned managed identities, and availability node support have all been added to batch pools. On the scheduler side, we've added some additional scheduling capabilities, but we've also done a lot of work to performance. And so we've significantly reduced the throttling rates in the scheduler, and so it kind of greatly improved overall user experience there. On the CycleCloud side, we've, as you saw before, we made some improvements to both PBS and Slurm integrations. I do want to call out for Slurm, we've added support for login nodes for high availability HA deployments, and also the ability to use node names as host names. But we've also done some Azure keep up there as well with the overall CycleCloud product. We've added disk encryption with customer managed keys and force delete support and several other features. And we also have updated the cluster cost API to give you additional insights into your spend. So that's those are the highlights and the highlights only of what has come since, the last time we talked. So what's coming soon? Well, more of the same, basically. So on the Azure Batch service, we're going to continue driving core service improvements, and that'll have a significantly improved overall user experience, scalability, stability, and security. For batch pools in particular, we are going to be releasing an updated version of the no public IP VM pools feature. So this is something that went preview last year, and we're actually releasing a new version of that feature in preview later this summer. And the goal is to go generally available several months after that. On the scheduler side, we're going to continue driving additional scheduling capabilities, whether it's improved fare share or improved overall throughput and performance. And on the CycleCloud side, we're going to drive core product improvements as well. Now, we already support SLES, the operating system with the LSF scheduler. We're going to build on that to drive across additional SLES integrations. And then we're going to keep driving those improvements to our scheduler integrations and collaborations, as well as minor bug fixes and updates and whatnot. And on the CycleCloud side, because these HPC environments are combinations of technologies, we're going to keep driving those partnerships, whether it's with software ISVs or other hardware vendors to provide additional HPC capabilities and make them available through CycleCloud. On the support side, it's a similar kind of drive with partnerships, but in support, it actually comes down to providing a smoother experience in understanding the issue in an environment comprised of multiple technologies and getting a better experience when you're using a combination of proprietary in-house technologies, open source technologies, third-party commercial technologies, and Azure HPC and AI technologies all in a single environment. And then we'll also be making improvements to our Azure portal and overall process of submitting questions and getting responses. As I said, I covered the highlights that we have released over the last year and giving kind of teasers as far as what's coming, at least in the short term, for our platform. But you can always get more detailed updates online through Azure Updates. You can see a screenshot there on the left of what Azure Batch capabilities were documented there. CycleCloud is also updated in Azure Updates, but CycleCloud includes release notes in the product documentation on Azure.com as well. So, the kind of dual mission I mentioned earlier, we have this workload orchestration where we want to give you that workload agility, and we want to give you the flexibility by both meeting you where you are with the tools and technologies you need, as well as providing tools that simplify using the broad compute, networking, and storage option that Azure provides. But that is wrapped up in that end-to-end experience. And I think almost nothing is more impactful than the support side of that. Azure is a bit unique. We have a worldwide 24/7 HPC and AI support team. They don't just support CycleCloud. They don't just support Batch. They don't just support HPC Cache or Azure NetApp Files or Azure Blob or any of the technologies that might go into this. They support HPC and AI environments that our customers are running. And they are staffed by genuine HPC experts. These are people that have deployed, these clusters. They have run massive distributed training of models and inferencing. They have, run fluid dynamics and autonomous driving resimulation workloads. And so they are there with a mission to help you solve your HPC and AI needs, and really kind of drive innovation and leadership of the overall HPC and AI customer experience. And we treat them as part of our product group, and we partner tightly with them to improve the experience of using our products and the experience of deploying these environments, but also to drive kind of future innovation in our own platform. And to help you and our partners and even internally understand our offerings and understand our space, we do have MS Learn. Now, these are free online content covering compute, storage, networking, advanced topics, introductory topics, you name it. Now we have new modules coming in the next year, but there's already over 13 free modules there. And as I mentioned, they cover everything from the introduction to high performance computing in Azure to choosing the best level of service for your Azure NetApp Files and otherwise configuring and deploying file systems to advanced optimization concerns and capabilities for HPC and AI workloads. So I highly recommend you check it out. aka.ms/HPC Learn. And as I said, we'll continue building that out. If the HPC Learn, by the way, is the specific HPC and AI kind of track, but there's tracks covering the breadth of Azure and Microsoft offerings. And if this kind of the mission that we're on kind of caught your eye, then we're always hiring. Come help us build the future of HPC and AI. You can go to careers.microsoft.com and check it out. We are trying to unlock scientists and engineers and quants and others to really solve some of humanity's most pressing problems. I've been in this space for 20 years, and that mission has kept me excited this entire time. And so if that mission excites you too, then check it out. Come be a part of a fun and ambitious team that supports each other, and will support you. So next steps, you can always go to azure.com, particularly the high performance computing site, to learn more about Azure for HPC. As I mentioned, you can go to mslearn/HPC Learn to get those access to those modules, learn about our technologies and how to deploy your solutions. You can always explore solutions for your specific industry through azure.com as well. And you can also engage partners. And overall, if you're excited, come join our team. So. Really appreciate your time today. I love talking about our platform. I love talking about our mission. And I love talking about how Azure really is the world's supercomputer. Thank you.